Good evening. Arianespace is preparing to carry out a second attempt for this fourth Ariane 5 launch of this year. You may remember on July 1st, during the first try, we had to stop the countdown because a problem arose in the cryogenic system inside the main cryogenic stage. Since then, we have focused all our efforts on solving the problem, along with ESA, CNES, and our industrial partners. And today, after several review sessions which we organized and in which our customers participated, we feel that we're now 100% ready and that the launcher is in the proper configuration that will let us carry out the final countdown, this time to the end. During these past weeks, the two satellites, Astra 1N and BSAT-3c JCSAT-110R, have been kept in maximum security conditions. As you can imagine, our customers are especially impatient to see their satellites in orbit. So that's what I suggest we do now. Let's watch this new launch of an Ariane 5 ECA, Astra 1N, and BSAT-3c JCSAT-110R. Greetings, everybody, wherever you may be, and welcome once again to Kourou, the home of the Ariane family, for tonight's live broadcast of Arianespace flight number 203, take 2. Joshua Jampel here, and as you can see in the upper right-hand corner, we're counting down, but there's a bit of a red. The situation is not particularly clear. We might start off in a red, hoping that it'll clear up by the time before the window runs out, but in any case, we'll have more information for you in a moment. We're proceeding with the countdown for the fourth launch of the year, 59th Ariane 5 and the 203rd in all since the program began. You see the green status panels there, red on the weather. These green status panels offer a real-time summary of the different launch services provided by the base. We check these panels from time to time during the first part of the mission before lifting off. The space base covers a lot of area. It's about the size of Singapore, actually. And the status of these services, and you saw them there, are the launch of the satellites, tracking station, safety, and the weather, are sent in here to Jupiter by the different outposts on the base, which is why we call Jupiter the nerve center of the space base. We like to set the scene introducing the major players responsible for the flight tonight. We'll begin here in the Flight Directorate with Arianespace top management. Jean-Yves Le Gall, Arianespace Chairman, CEO, you saw. Patrick Loire, head of the Arianespace Kourou facilities here. He's the first link with the launch base here, and as the local contact, any problem comes up, he's the first to know, and he passes the information to the others. Edward Parez, the living technical memory, Arianespace's top technical person. We're lifting 9 tons tonight, which of course is only possible with the heavy lift Ariane 5, the only commercial launch vehicle capable of lifting 2 big passengers. The CSG is, of course, the world's only dedicated commercial space base. We're counting down under 10 minutes to go for the launch tonight. But before we go any farther, back with more, but the latest news first from Arianespace.
In June, Arianespace participated in the SATCOM Africa trade show. The company helps develop telecoms for the continent, recently by launching RASCOM CAF-1R and NILSAT last year, and Intelsat New Dawn in April.
Arianespace, ESA, and the European Commission have announced that the first 2 satellites in Europe's Galileo GPS program will be launched by the first Soyuz mission from French Guiana on October 20th.
The 2011 Icarus Prize, honoring a personality in the space sector, was awarded to Jean-Yves Le Gall. Mr. Le Gall received the prize for his industrial and commercial success.
Arianespace confirmed its leadership of the global satellite market at the 49th Paris Air Show at Le Bourget Airport last June and highlighted its family of launchers during official visits by both the French and Russian prime ministers and other political leaders from France and Europe. Since its founding in 1980, Arianespace has signed over 300 launch contracts and orbited nearly 300 satellites.
Also at the Paris Air Show, Arianespace signed to launch Astra 5B for SES. The 5.8-ton satellite will be delivered by an Ariane 5 in mid-2013.
Arianespace signed to launch Thor 7 for operator Telenor in 2013. It's the second satellite launched by Ariane for Telenor. The first, Thor 6, went up in October 2009. Finally, on July 13th, Arianespace and StarSem orbited 6 new satellites in the Globalstar 2 constellation. It was the 23rd straight success for StarSem. The first 6 Globalstar 2s were successfully orbited by Arianespace and StarSem in October of 2010, also on a Soyuz. Aside from tonight's launch, Arianespace will orbit SES-2 for the Luxembourg-based SES group that comes later this year. Outside, waiting, Ariane on the pad. Inside, Jupiter, where of course we come to you live with our broadcast with every launch. We're going to continue our introduction of the Duramatis Personae, the people responsible. This is the commercial side. Arianespace offers a one-stop shop for all the customers, a single interface from well before signature of the contract to well after the launch. Véronique Loisel, Luca Chiecchio, program directors for each satellite, Astra and BSAT JSAT, respectively. They're the Ariane point persons for the customers. The program director on a day-to-day basis meets with his or her customers, reviewing the status of their satellites. Other key players, Didier Saïd is the mission director. He's an Arianespace person, and he's the daily coordinator with the satellites and their campaign. And with him, Bruno Gilles, tonight, the DDO, or the Range Operations Manager, a CNES person, and it's his voice you'll be hearing during the countdown and afterward when we're airborne, calling out the major milestones in the flight, stage separations and confirmations of steps taken. Every day these teams are making sure that hundreds of campaign operations are going according to plan, and any unforeseen problems are called, of course. Bruno Gilles is going to call out the 7-minute mark in just a moment, which is one of the final milestones in the countdown.
À tour de DDO, arrêt du décompte suite au rouge lié aux conditions de vent en altitude, que les moyens restent prêts pour le démarrage du décompte dès le retour au vert.
Okay, so he said we are stopping the countdown at the 7-minute mark. You can see the clock is no longer running. He did mention a reason, weather, high altitude winds. Now this is a problem that we have sometimes in the winter months, January and February. In August it might be unusual. It might have something to do with the hurricane a bit to the north of us in the French West Indies, but I don't want to speculate. In any case, we are stopping the countdown. As you see the status panels there, which are a go, no-go, green or red resume of everything it takes to successfully launch Ariane. Green means okay. Red means, of course, the opposite. It's very simple. If we get a red in any of these areas, we stop the countdown. It happened on July 1st, and here we are again. But they are checking I guess they're waiting for the weather reports to see if we can go inside the launch window before the launch window runs out. Now sometimes we get a red during the countdown. It can happen, of course, any time, and it represents something unexpected. The engineers here begin immediately to examine it and try and identify it, and eventually to see if they can correct it before the window runs out. Now, the window tonight is over an hour, so if the weather clears up before then, we can go, of course. This is a little different. The red is a weather, and I guess it's been identified. Very often it is not. So I'm assuming it's the same problem we had last night when we were supposed to launch, but the weather was not cooperative. For the weather aspects, Ariane 5 can launch in the rain. It can launch any time. Rain is not a problem, and it rains a lot here. If rain were a problem, we wouldn't have a space base in French Guiana. Ariane does fear lightning, which can pose a big problem. If you see those four what look like radio towers around Ariane, though, those are actually lightning rods around the pad. She also fears high altitude winds, which can, I guess, blow her off course, which is perhaps what we have tonight. I say that because it's what we had last night. So what's happening in a red procedure like we have now, we stop. Red is like a stop sign, basically. We stop and think. People examine the problem or something that's outside of a parameter and decide what to do. I think we're going to give you a break, and we're going to go to a recorded subject, I think, on the weather, so we can get some more information. We'll be back when we have some more information in just a moment.
The authorization to launch is often dependent on circumstances beyond our control, the weather. All we can do is forecast it and consequently be ready. To anticipate this natural phenomenon, the launch base is equipped with the specific meteorological center, where we are at the moment. Bruno Jacquemin is responsible for the CSG Meteorological Center, and he's going to explain to us the methods of collection and analysis of climate information.
We need to distinguish between meteorology criteria per se, the risks of lightning on the launcher on the ground, but especially in flight, where the launcher is heavily exposed. Just after it is launched, it leaves the thunder-protected facilities and becomes highly exposed to the risk of lightning.
A cloud changes constantly, and each stage of its development represents different risks which it is essential to know.
The vertical extension of clouds is highly variable and very important to our activities. A small cloud which culminates towards 2,000 or 3,000 meters is quite innocuous, but a cloud which culminates towards 7 or 8 kilometers is a pre-storm warning. It starts building electricity inside. And in its maximum development in Guyana, a cloud can reach 17 kilometers. It is considerable compared with temperate latitudes of our cities. In July and August, in the Guyana sky, these clouds are 50% higher.
To visualize these clouds, the Meteorological Center is equipped with radar, which enables us to have images of the three-dimensional cloud coverage.
During the launch period, we have our meteorological radars operating at a faster speed to be able to have a volumetric characterization of the atmosphere, a sort of 3D X-ray, which enables us to know the position and especially the extension of the clouds, and in order to know if the clouds present a risk of lightning for the launcher. If such is the case, the launch is delayed, generally until the cloud leaves, and then the launcher can take off.
The ground winds are measured using an anemometer installed in the center of the base. The speed of the winds will determine the subsequent operations.
The ground winds are carefully measured when the launcher is transferred from one building to another, when it is stationary on the launch zone, and when it is launched.
These meteorological constraints are not the only ones to be taken into account for the launch. The flight phase also requires special attention.
To measure the wind profile in altitude and transmit this information to the safety department, we usually use balloon probes, which can be dilated, inflated with helium, which culminate at 30 kilometers in altitude, sometimes a bit less, under which we attach this small instrument which measures temperature and humidity. It is equipped with a GPS antenna in order to know the position and which retransmits all this data by frequency modulation. Thus, the successive positions of the radio probe as it is rising would allow us to reduce the variations of the vertical profile of wind in altitude and therefore the wind which is vertical to the launcher.
The wind in altitude constitutes an important factor in authorizing the launch. A very high speed may be dangerous for the launcher in flight. The orientation must guarantee the safety of the civil population in the event of launcher elements falling to the ground.
Naturally, once the launch has taken place, we do not shut down all equipment. The weather radar is constantly on and continues to disseminate regularly and continuously all detection of rainy zones to Météo France, and all our measuring devices on a mass of automatic stations continue to record data that have obtained from Météo France, which benefits all the regional meteorological community.
These safeguard criteria instigated by the CNES CSG enable Arianespace to guarantee their client campaigns and launches with maximum safety.
If you just joined us, you see that we are stopped. We're having a hold in the countdown, -7 minutes, the red on the weather. At T-7 hours is the first weather check. And based on this check, we decide to start the chill down of the cryogenic fuel lines, which must be maintained very cold. There's another weather check at T-4.5 hours. This determines whether or not we start filling the main cryogenic tanks. Now, we passed both those weather checks, apparently, but there's another one at -20 minutes before liftoff. Apparently, that's the one that has stopped us. So we are holding, for the moment, still more than an hour to go in the launch window. So I think what we'll do is cut away and wait until the weather clears up, if it does, and get some more information in the meantime. You're watching Arianespace flight number 203. We're going to be launching Astra 1N and BSAT-3c JCSAT-110R. And you can follow, of course, everything on the website. We'll leave you now and be back when we have some more information very shortly, we hope.
À Toul de DDO, retour au vert des conditions de vent en altitude. Attention pour la reprise du temps des comptes. 3, 2, 1, top. Reprise du temps des comptes.
All right, welcome back. You can see the clock is running again.
Le nouveau H0 est 22h52 et 30 secondes en temps universel.
All right, the DDO says we're back in action. We have a new H0, a new launch time. These high-altitude winds are dangerous because they can blow the launcher off course and destroy it, which obviously puts people and property below at risk. This is why Arianespace takes particular care in situations like this. But apparently the winds have died down. The computer is analyzing the data from the sounding balloons, have given the okay to resume the countdown. So we are back. The space base here, we mentioned it's a large area, 1,500 people working around the base in all. Another place which is very busy tonight is the launch zone, as you can imagine, where the launch management teams are. And you're looking at them now. They're closer to the pad than we are here in Jupiter, about 14 kilometers to the northwest of us in Jupiter, and about a kilometer from the pad. Basically, you're looking at three teams. One coordinates the launcher campaign and the countdown. They're doing that right now, or the launch vehicle. A second crew guarantees flight readiness and signs off on the okay to fly, and before that on the okay to transfer Ariane from the final assembly building to the launch pad. There's a third team up there which is independent from these two. That's a quality team. All in all, about 200 people, and we need them all because, as you can imagine, Ariane 5, a very complex bit of machinery, hundreds and hundreds and hundreds of things have to be functioning perfectly. And Arianespace will only give the green light to go if they are. And we had a good example of that during the hold. Other players tonight, the satellite mission directors. You're looking down at these two gentlemen. They're responsible for the chronology. They decide if their satellite is ready for launch. They follow the campaign and its preparation as a manager, meeting with their teams and giving the okay for each stage of the satellite's preparation. Every Ariane customer has one, just like they have the program director. We saw Veronique and Luca earlier. The space base here in, well, we have no time for that. We'll go to look at the launch vehicle. If you're looking at us, Ariane for the first time, she stands 50 meters tall. Ariane 5 is in two halves. They call them composites. The lower composite consisting of the main stage and the two strap-on boosters on either side. The upper composite, the upper stage, cryogenic propulsion just like the lower stage, and on top of that the nose cone, that's the fairing with the logos on it, and inside the fairing are the two satellites, and we'll take a look at them in just a minute. The range services we mentioned here, they're very active during a mission, of course, in Jupiter and in the launch zone, as we mentioned. And there's one other one, which is the CVI. That's the Immediate Flight Control Center, where the telemetry comes in. And that's in the Montagne des Pères. That's just behind us here in Jupiter. Other satellite mission directors now from the BSAT, JCSAT side. Tonight represents long months, years sometimes, of work for these people. That's one reason why everyone is, you can see, focused on their computer screens or on their telephones. We're working with high technology. It is rocket science, after all, but there is a human side. It's why we like to introduce the key players. Nice shot of the launcher on the pad. We have a new launch 0 now, so we should be ready to go very shortly, coming up to 3 minutes. Before that, I'll look at the satellites. There was the fairings and the traditional logos on the fairings. Inside, the two passengers, the upper passenger, Astra tonight, to be separated first. Normally, the upper passenger is the heavier one. Not always, but typically. Tonight, you see Astra is the heavier satellite, over 3 tons. Under that, you see the black bell-shaped structure called the Silda. That's a carrying apparatus, which allows us to have the second satellite. And inside, as you can see, is BSAT, JCSAT, the lighter satellite, just under 3 tons. So will be separated last. The satellites are placed in position in the final assembly building. That's one of the main facilities here, and the tallest. It's about 90 meters tall. Ariane, remember, standing 50 meters tall. While they're there, they're kept at minus 20 degrees by the air conditioning systems. And now on board, the temperature is kept at 14 degrees Celsius, of course. Coming up on 2 minutes until liftoff, we're going to zoom in on the cryogenic arms. You see the yellow bars in the middle of the screen. Those are the cryogenic arms, also called the propellant feeder arms, because they're feeding the propellant into the upper stage. This is a split screen image of that. On the left, liquid hydrogen. On the right, liquid oxygen. The upper stage needs to be refilled up to the last minute. Why? Because the cryogenic fuel is very, very cold propellant, and it evaporates in this heat here in French Guiana. When I say cold, liquid oxygen at minus 160 degrees Celsius and liquid hydrogen minus 240 degrees. So it requires constant topping up. Those of you who've been to French Guiana here, or those of you here tonight, you know what I mean, evaporating in this heat. All those propellants fabricated here in French Guiana.
Attention pour moins 1 minute.
The DDO is going to call out the 1 minute mark.
Top, H-1 minute.
All right, we're into the final 60 seconds of the countdown here. Now here's what to watch for. We focused on those propellant feeder arms, the yellow bars. The sequence, the ignition sequence begins with these cryogenic arms, the yellow bars there. They pull back at minus 5 seconds. You'll hear the DDO call out to 5, which is of course French for 5, and then they retract. At 0, the DDO will call out allumage, which is ignition, and then the main engine will light, but we do not lift off. Count to 7 once you have CNH 0. For 7 full seconds, the computers are going to be checking the main engine while it's burning on the pad. They check it twice to confirm it. Better to do this on the ground than once we're airborne, of course. If all is well, then and only then they give the order to light the boosters, and we're off.
Attention pour le décompte final.
Final countdown. We'll be back after Ariane has cleared the tower.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité 0. Allumage du moteur Vulcain. Allumage des EAP, décollage. à bord sont normaux.
So, right on time with the new launch window, Ariane began her mission blasting off the pad, leaving the trail of gold behind her. Very clear shots. We mentioned that the skies have been very clear, and beautiful images for the people on the beaches and around the base here with their cameras. Our cameraman, René Zamor, is out on the balcony following Ariane flight.
Paramètres à bord sont normaux.
The DDO saying that everything on board is normal. 774 tons now at liftoff as Ariane leaves the ground. She's burning 5 tons of fuel per second. Yes, you heard that right, 5 tons per second. That's 2.5 tons burning in each booster. And the core stage is burning another 300 kilos of fuel per second. Ariane now following the program in the onboard computer, which gives all the orders, including the stage separations, which we will soon see. And I imagine we'll be able to see the booster separation with the eye unaided because the skies are so clear. It has been known to happen. We're in the first of 4 flight phases. The first 3 are powered. The last is not. We will describe each in turn and in detail so you can follow Ariane as she heads across the Atlantic, where she'll separate the satellites after passing over Africa. Right now, the first flight phase, the single Vulcan core stage engine and the 2 boosters are burning. They're going to burn for another, I would say, 5 or 6 seconds, and they'll be the first to be extinguished. And it looks like they are right on time. That looks like the flame out of the boosters. There it is, right on time. You saw that with the unaided eye. That's wonderful. The DDO has called out confirmation of that. This is what it looks like up there. There's another booster out of camera range on the left, but they're dropped back 500 kilometers from shore in an unprotected area. Beautiful shot there. You see the main engine burning on the right and the 2 boosters falling away to the left and below. We may be able to see the fairing separation with the unaided eye. Take a look at the curve on the upper left. On the upper left, you have the cursor crawling up the line there. The cursor represents the actual real-time trajectory. And the line there represents the optimum trajectory. As long as one is on the other, we're right where we should be. On the lower left, the 2 bottom lines, A and V. A is the altitude, 111 kilometers, and V is the speed. You see 2.25 kilometers per second. And the DDO has just called out separation, I should say, of the fairing. You see how that happens. There's another half, which is blown away outside, out of camera range on the right. The fairing is dropped at over 100 kilometers, and you can see exposing Astra now, the gold and blue box, to the confines of space. We're going to go to a recap of what happened on July 1st and everything that's happened since. During the first launch attempt, the countdown was stopped during the synchronized sequence because a hydrogen feed valve in the main stage did not open. Water in some of the hoses in the main stage was identified as the cause.
This high level of hygrometry prevents the valve and other regulation systems of this stage from functioning properly. They must be able to operate at very low temperatures of between -250 and -269 degrees Celsius. At these temperatures, water freezes to a very hard solid and prevents the moving parts of this mechanism from operating. This high level of humidity is the main cause of the anomaly encountered. Once the cause had been identified, we took corrective action to ensure proper operation of the cryogenic systems. This consisted in blowing dry helium through all the cryogenic lines to achieve a very low level of hygrometry and rule out malfunctioning of the systems exposed to the cryogenic environment.
Arianespace, together with ESA, CNES, and the industrial partners, set up a task force to solve the problem. It's an approach that's key to the success of the Ariane 5 system.
The teams work very hard 6 days a week to achieve the objectives Edouard was just describing. For the future, we have initiated further studies aimed at improving the drying procedure applied to these lines and the traceability of corresponding operations. Finally, we think it's important to introduce independent supervision of suppliers to detect anomalies in these pipes early in the integration process.
Thanks to the work carried out by these dedicated teams, both at the space base in Kourou and in Europe, the launcher was declared flight-worthy by the Launch Readiness Review, giving the green light for tonight.
Our action plan enables us to resume the countdown this evening in compliance with all the cryogenic requirements after correcting all the causes and consequences of the anomaly encountered on July 1st.
Okay, so now you know all about that. You also know that Soyuz and Vega are coming to the CSG. Instead of one launcher, we'll have 3 very soon. Take a look now at this film on the Ariane family.
Since the start of 2011, Arianespace has been fully involved in the exploitation of the 3 launch systems, Ariane, Soyuz and Vega. Our operational teams in the Operations Division are now deployed on all 3 fronts, the 3 launch pads at the Guyana Space Center. For Ariane, we're going to pursue the preparation and exploitation of the Ariane launch vehicle. Since the start of the year, we have had 3 launches in 3 months.
In April, Arianespace, with its Russian partners, performed qualification tests on the Soyuz launch base. This included a full dry run rehearsal of all countdown procedures, including transfer of the vehicle to the launch zone.
The success of this test, which was carried out in early May, has made it possible for us to plan the first launch of Soyuz for the 20th of October. In other words, as soon as the Galileo satellites, which are the passengers, are here in French Guiana.
Arianespace is bringing its technical and operational know-how, the fruit of 30 years' experience, to supervise the Vega qualification campaigns.
We are drawing on the experience of our teams in the context of Ariane, and also we're familiarizing ourselves with the installations that we'll be responsible for in the short term. The success of this qualification campaign will make it possible to plan the first launch for the end of the year.
Arianespace doesn't only provide launch service and solutions, it offers a complete range of services for its customers.
In the interests of our customers, Arianespace has a long-term partnership with the space insurance sector on the basis of a technical transparency and communications policy that's highly developed. This partnership makes it possible for us to have a real relationship of trust with all of the players in the space insurance market.
The world's first space transportation company, Arianespace, remains the leader in launch service and solutions.
The simultaneous deployment of our operational teams on the 3 launch sites is a concrete illustration of Arianespace's strategy. For us, with this simultaneous exploitation of the 3 launch sites, we're offering a unique launch service, which is the world reference.
We are coming up on the end of the first stage burn, which is burned for about 10 minutes. This will mark roughly the end of the first half of the mission, and the DDO has called out separation of the lower stage. You can see how that happens, and the ignition of the upper stage he has just called out. These are 3 orders: extinction of the lower stage, separation of the lower stage, and ignition of the upper stage, which are given by the onboard computer in about 12 or 13 seconds. You see what's left of the composite there. From our 775 tons at liftoff, we're down to about 26 tons. We have 2 satellites and some adapters and the Silda, the carrying structure, which we'll talk about in a moment, and the vehicle equipment bay and the computers. All is going well. You see our altitude on the left, on the bottom left, and the speed 7 kilometers per second. We need to be between 8 and 9 kilometers per second to inject the satellites, so watch for that. In the second half of the mission, we can start to focus on the satellites. The first of some films now, beginning with a long friendship between Ariane and Astra.
It was over 2 years ago that, together with the project SES and Astra teams, we began preparing the Astra 110 mission.
The mission of the Astra 110 satellite is replacement capacity at the 19.2 degrees east longitude hot orbital position. This is where Astra operates its direct-to-home television services. It's actually going to start off at 28.2 degrees east, though, for a period of time until another satellite is able to come in there and replace it. When it's at 28.2, it's going to be serving the British Isles for direct-to-home service there, too. It should start its service at 28.2 around mid-September.
This cooperation dates back more than 25 years, and so far 23 satellites have been launched.
We have experts from Arianespace that are available to answer the questions that we have about the rocket preparations, and they're very knowledgeable and very open about answering these questions. And for us, this is actually very important. We also have, the technical people from the satellite manufacturer. In this case, it's Astra, knowledgeable, very transparent about the preparations of the satellite itself.
We are delighted to see this cooperation continuing with the recent signature of the Astra 5B launch contract, the imminent arrival in French Guiana of SES-2, and of course, this evening's launch.
We had a very special event during this particular launch campaign, the signing of the fairing logo on the launch vehicle. We have the Astra logo, but we also have a Bild logo there. And Bild is a daily newspaper in Germany, and they're helping us get the message out to convert existing analog television subscribers to digital.
We are in the third and final powered flight phase. The second stage will burn for 16 minutes in all, 13 minutes to go, burning 12 tons of liquid oxygen and 2.5 tons of liquid hydrogen. I want to say hello to our friends at Betzdorf in Luxembourg and at Newtown, Pennsylvania. For Lockheed Martin, we hope all of you are enjoying yourselves and enjoying your afternoon and evening. A short film now on Astrium, builders of Astra 1N. Words, no music. What did I say? Words, no music? Well, it was just the opposite, of course. Sorry about that. We've been picked up by Ascension Island, has picked up the signal from the launch vehicle. That's our second downrange tracking station. Tiny island in the South Atlantic, 10 square kilometers, belongs to the UK. NASA had a station there till 1989, and they closed it, and ESA decided to build its own. With 9 minutes left in the second stage burn, a word now from SES Astra, owners and operators of the Astra fleet.
Arianespace relationship has been excellent. We've worked with them since our very first satellite launch, which was Astra 1A. Since then, the record has been faultless. We work with them very closely within our multiple launch agreement, and they've been our long-term partner. They're our path into space, and we wish to have them as a partner for the foreseeable future. Astra 1N is an interesting satellite. It's a European satellite built by Astra, and we're actually going to use a European launch vehicle today. Just to give you a little bit of information about Astra 1N. Launch mass, when it actually leaves the ground, is around about 5.3 tons. And then it takes us around about almost 3 tons of fuel to actually make a geostationary orbit. So the final mass when it actually gets into orbit is around about 2,370 kilos. We're looking for around about 16.1 years of life from this satellite. We have 62 Ku band transponders installed, of which around about 52 will be active at the beginning of life. And the solar array generates around about 13.5 kilowatts. Arianespace, of course, are extremely reliable launch vehicle. They also are extremely flexible. They allow us to launch both large and small satellites on the Ariane 5 launch vehicle. In addition, they allow us the flexibility of the Soyuz vehicle as well, which we may use sometime in the future on other launches and missions. I'd just like to take this opportunity to thank the various different teams that have worked on this mission, to thank Arianespace for all the efforts to prepare ourselves for this, and also to thank the SES team in Toulouse, who have worked so hard to get this satellite ready for launch. Thanks very much, guys. We really do appreciate your efforts.
A nice complete rundown by Martin Hallowell on his satellite, Astra 1N. Both the first and second stages use cryogenic propellant. Both have single engines. But the role of the upper stage has another role besides power. It pushes Ariane 5 across the Atlantic to where she can separate the passengers. But she also has a second role apart from propulsion, and that comes during Ariane 5's ballistics phase. After the powered phases are over, we mentioned there's 4 flight phases. The last is unpowered. This comes a little later on in the flight. We'll describe that in detail because there's a lot to talk about, and because we'll also have a little bit of time. For now, turning to the Japanese satellite, a film on Lockheed Martin and its work over the years with Arianespace.
BSAT-3c JCSAT-110R is a turnkey program run by Lockheed Martin on behalf of BSAT and SkyPerfect JSAT.
The BSAT-3c JCSAT-110R satellite is a little unique. As indicated by the name, there are 2 customers that are procuring the satellite. Lockheed Martin is very pleased and privileged to be working with 2 such experienced and astute customers. Both BSAT and SkyPerfect JSAT have been in the satellite industry for many, many years. It has been a tremendous advantage to be able to leverage the resources of all 3 organizations in order to work toward a common goal of developing and delivering a satellite that will perform on orbit flawlessly.
Lockheed Martin has contracted the launch to Arianespace and will deliver the spacecraft to the customers, SkyPerfect JSAT and BSAT, once the satellite is in its final orbit.
Arianespace's record of success with the Ariane 5 is unparalleled. At the end of the day, all the effort that you put into making a perfect satellite would go for naught if it weren't for the satellite being put in the proper orbit.
Arianespace has launched 41 satellites for Lockheed Martin, 16 for SkyPerfect JSAT and all the BSAT satellites. This is because we tune our service to the customer needs. We have a process that constantly takes into account the experience of the past launches and the changing customer requests.
41 satellites launched by Ariane for Lockheed Martin. The Lockheed Martin people come here regularly. They know the Ariane facilities well and feel quite at home here. 5 minutes left in the second stage burn. Ariane 5 performing flawlessly. Our altitude 240 kilometers and the speed 8.5 kilometers per second. We have been picked up by our next downrange tracking station. That's at Libreville. That's in the west coast of Africa, about 30 kilometers from the capital at Gabon. It will receive the telemetry for about a quarter of an hour. For more on BSAT JCSAT, we go to our next film now by Lockheed Martin.
Lockheed Martin is proud to partner with our customers, BSAT Corporation and Sky Perfect JSAT Corporation, to deliver the BSAT-3c JCSAT-110R broadcasting and telecommunications satellite. Based on the award-winning A2100 satellite, BSAT-3c JCSAT-110R will operate at 110 degrees east and has a design life of 15 years. BSAT-3c JCSAT-110R's two independent Ku-band payloads incorporate 12 direct broadcast channels and 12 FSS direct-to-home channels with uplink and downlink coverage over Japan. BSAT-3c JCSAT-110R is the 38th of Lockheed Martin's award-winning A2100 series of commercial spacecraft delivered to satellite operators around the world. The A2100 spacecraft's modular and scalable design accommodates a large range of communication payloads. Its designed-in modularity enables the A2100 spacecraft to also support medium Earth orbit navigation missions and geostationary Earth orbit-based Earth observing missions. Lockheed Martin provides the best overall value for our customers' investments in satellite broadcasting systems, satellite communication systems, and support services. Throughout our more than half-a-century track record of excellence in space, our customers have come to recognize us for superior technical capabilities, design and engineering, manufacturing, operations, support, and problem solving. Lockheed Martin's A2100 satellite is the product of choice when considering reliability, performance, and credible price and delivery schedule. It has the lowest total cost of ownership based on satellite cost, insurance, and operational costs, and has a highly reliable, proven record of success.
3 minutes left in the second stage burn. The last launches for our two customers tonight for Astra, Flight 194, that's in May of last year. That was Astra 3b, and that was a milestone flight, the 50th, 50, Ariane 5. The last two Japanese launches were for the two partners tonight, curiously enough. Flight 197 back in October of 2010, that was BSAT-3b. And Flight 190 in August of 2009 was JCSAT-12. The industry reports, the last ones I read, expect 200 million homes to be receiving DTH by 2016 in some 75 countries. So you see, our two passengers tonight, both DTH satellites, are filling a market need. Arianespace, as you know, has a high profile in Japan. We go now to our Tokyo office.
This year, 2011, is the 25th anniversary of Arianespace Tokyo office. Arianespace opened its Tokyo office in 1986. And 3 years later, we launched Japan's first commercial telecommunications satellite, JCSAT-1. After that, thanks to the support and the partnership with our customers and the Japanese friends, we are very successful in Japan. Our market share in Japan is 75%. Japan is important for Arianespace. So Tokyo office is continue to be very active to even more enhance relationship with the partners, with our customers and friends. BSAT-3c JCSAT-110R is a satellite co-procured by our two most important customers in Japan. Today, I am very happy to launch such an important satellite in the year of this memorial year of the 25th anniversary of Arianespace Tokyo office.
We have been picked up while you were watching that film by our last downrange tracking station at Malindi in the east coast of Africa in Kenya. We opened a fifth tracking station there for Ariane 5 on her second launch in 1997. It will receive Ariane 5 data the longest for about 3 hours after liftoff and see the upper stage burnout and satellite separations. And then upper stage burnout due to come in about 15 seconds. And we're awaiting that call from the range operations manager, and then we'll be finished with the powered flight phases, and we'll be into what we call the ballistics phase, and we can give you an idea of what that's like. We'll wait for the DDO.
Fin de propulsion du deuxième étage sur commande de guidage.
And there it is, this upper stage shutdown, and we'll see an animation of what that looks like. You see the nozzle shutting down there. So we're out of power, but you see the nozzles popping on and off. We'll have a word on that in just a minute. The cutoff command given by the onboard computer at about 650, over 650 kilometers up. A word now from Astra's Rick Starkovs on what will happen to his satellite after separation.
Right after the separation of the spacecraft from the launcher, there's a number of steps that need to be taken. The first is just to acquire the signal from the spacecraft to initialize propulsion system. And soon after that, we'll begin orbit raising for 6 days, where we do 4 apogee burns to circularize the orbit. Right after that, we'll do the deployments of the solar array and the antenna reflectors. As soon as that is complete, we'll begin the testing of the platforms. Some people call it the bus. And the test of the antenna mapping and the payload repeater will take place for about the next month. We'll need to relocate the spacecraft from its in-orbit test longitude to the longitude where it's going to operate at, which will be 28.2 degrees east longitude. So those are the main steps that we'll need to take right after separation.
So Ariane 5 has reached her top speed, which was 9.35 kilometers per second. You can see that on the lower left. In this phase, this ballistics phase, the spinning in the orientation phase, she will actually begin to lose speed, and you can see it happening there. This is quite normal. By the time she separates Astra 1N, that's at in about 12 seconds, she'll be traveling at about 9.08 kilometers per second. So we're going to wait for the DDO to call out confirmation of separation of Astra 1N.
Séparation Astra 1N.
So there you are. You saw some happy gestures there from the Astra people. You see how that happens. The satellite is pushed away from the mothership, a series of springs, and we'll have a little explanation on that in a minute. So there's the first good news. Separation coming right on time and on target. Ariane 5 over the east coast of Africa. Now, you noticed in the hall here the people in Jupiter very politely holding their applause until separation of our second passenger. It's become something of a tradition here. Now that Astra is separated, you heard from Rick Starkovs before giving a very complete rundown of the launch and early orbit phases. I don't think he mentioned a couple of things, though. Let me add. He talked about the apogee motor firings and deployment and all. He didn't mention, I don't think, in 12 days, satellite control will be transferred to Betzdorf. And in about a month and a half, roughly, completion of the in-orbit testing and ready for service shortly thereafter. Now, satellite separation marks, of course, an end as well as a beginning. It's the end of the launch vehicle mission for this satellite, Ariane's mission for the second passenger continuing, of course, but it's beginning also of the satellite's own life. Before explaining how a satellite is separated, just a quick idea on how it's attached to the upper stage. The satellite's basically a cylinder or a square fixed on an adapter using a clamp. And the clamp encircles the satellite, keeping it in place. Separation is triggered by the clamp, which is cut at one point and becomes loose. Now, this frees the satellite from the adapter and releasing 8 springs, which push it forward, as you saw. Our next film on our next passenger, BSAT JCSAT. We'll be back.
Broadcasting satellites are controlled from the ground at the main control center in Kawaguchi City, Saitama, and from the backup control station in Kimitsu City, Chiba. Satellites are controlled 24 hours a day. To maintain stable reception of airwaves, operators control the satellites and their orbital positions through continuous observation. The program signals sent from program supplying broadcasters are transmitted to our broadcasting satellites from our uplink center. The uplink centers are located in Shibuya, Tokyo, and Shobumachi in Saitama Prefecture, 50 kilometers from Shibuya. In the event of signal level attenuation by heavy rain, it is possible to instantly switch operation from one center to the other. These satellites will enable us to increase the number of channels and to conduct experiments on superior technologies. True to our motto of safety and reliability, through the cooperation with our program supplying broadcasters, we at BSAT, the Broadcasting Satellite System Corporation, will continue our efforts and investments for the future growth of BS broadcasting.
We mentioned that the upper stage has this dual role, propulsion and ballistic. Well, it's carrying out this second role right now. We're coasting. Remember, no more propulsion, but that doesn't mean that nothing is happening. The composite is being maneuvered and spun in a series of 20 operations tonight. They change, of course, with every mission. These operations range in time from 3 seconds to over 5 minutes tonight. We have to separate the first satellite in one direction, as you saw with Astra. Then the Silda, that's the black bell-shaped structure on the right, has to be separated in a second direction and at a second altitude. And finally, the second passenger has to be separated at another altitude and yet in a third direction. It's a lot of maneuvers, as you can see the composite being shifted, and you can see the nozzles popping on and off. They call it a space ballet in the trade, which is not a bad term. A film now on our second passenger and one of its owners, Sky Perfect JSAT Corp.
400 years after Galileo first turned his telescope toward the heavens, a new group of people filled with the same pioneer spirit also have their eyes on the skies. Their name is Sky Perfect JSAT. For all the things that make life special, Sky Perfect JSAT is determined to pioneer the future of broadcasting and communications. Sky Perfect JSAT is the world's 5th largest satellite communications provider in terms of sales. Japan's only satellite communications operator, Sky Perfect JSAT has a fleet of 12 satellites, making the company the largest satellite operator in Asia. In addition to Japan, Asia, and Oceania, a partnership with Intelsat enables Sky Perfect JSAT to cover Hawaii and all of North America, providing these regions with a broad selection of satellite communication services. Our satellite communications network is used not only for broadcasting Sky Perfect TV services, but also for sending and relaying video signals on behalf of terrestrial broadcasting stations and much more. From emergency backup links to disaster readiness and crisis management data infrastructure, we also offer a multitude of special applications that maximize the advantages of satellite communications. These services support people in a myriad of ways, bringing value down to Earth. We are Sky Perfect JSAT Corporation.
Separation of the Silda, that's the carrying structure for the second passenger, due to come in about 3 minutes, in exactly 3 minutes from now. There are 6 versions of the Silda, ranging in size from 4.9 to 6.4 meters. You see it there on the left, the black bell shape. And we're using the big one tonight. Lets us carry, as I said, the second passenger. We've used it well over 100 times. The first time we used on flight number 5, way back in 1982, of course, Ariane trademark for the double launches. Underneath the black bell shape is the vehicle equipment bay. That's the white band where the computers are. And you see the nozzles continuing to pop on and off, orienting the composite, where she's going to separate the Silda. They can move the composite in any direction, yaw, pitch, and roll. And this is how the upper stage performs all these 20 maneuvers that we were mentioning to separate the spacecraft and the Silda in the most precise spots, exactly where they should be. Final film now on what will happen when BSAT JSAT is separated in 4 minutes.
After separation, the satellite is acquired by the ground station. We then perform orbit-raising maneuvers to position the satellite in its final geostationary orbit. And after a series of in-orbit testing to make sure the satellite's working properly, we hand over officially the spacecraft to our customers. It is always a good experience to work with the Arianespace and Kinetic teams, But in this campaign, the processing of the satellite at S5 was the smoothest I've ever seen.
Separation of the SILD in a little over 1 minute. I think we have time to slip in the quiz question here. Arianespace quiz question number 203. Anybody at Astra or our Japanese friends or at Ariane, see if you can get this one. Are you ready? Here's your question. Like tonight, an Astra satellite and a Japanese satellite have flown together on an Ariane twice before. Can you name one or both of those flights, their dates, or the passengers? Once again, Arianespace quiz question number 203. Like tonight, an Astra satellite and a Japanese satellite have flown together on an Ariane twice, not once, but twice before. Can you give us the name of one of those flights, or both of them, their dates, or their passengers? If you have an answer, hold on to it, and we'll give you our answer in just a minute. But before then, looking ahead to the separation, the satellites, of course, go to geostationary transfer orbit, which will mark the end of the Ariane mission, but just beginning life for the satellites. Ariane puts satellites into a transfer orbit, and the satellites have to get their final slots under their own power. And getting to the final orbit can use up a lot of their onboard fuel, and that fuel is its lifeline. It's important to save fuel, and Ariane does this, like tonight, every mission by what they call optimizing the trajectory, since we're able to orbit 10 tons.
Du système de lancement double Ariane.
The DDO is called the separation of the SILDA, right on time and on target at over 3,000 kilometers. Up, you see, pushed away from the mothership with the same series of springs as before, revealing BSAT, JCSAT. Ariane 5 still slowing. The speed at SILDA separation is about 7.6 kilometers per second. Separation of the Japanese satellite due to come at 38 minutes and 11 seconds, just in about 1 minute. Just a very quick word on another Ariane mission which has been successfully completed, the ATV, which was launched on February 16th and docked with the space station on the 24th, delivering propellant and food and dry cargo. A new chapter in the ATV adventure has already opened because we're waiting for the ATV-3 to be delivered here. The Eduardo Arnaldi, scheduled to launch in March. That'll be here before you know it. The Kepler successfully completed its mission and was deorbited and burned up in Earth's atmosphere over an uninhabited part of the South Pacific. So that's ATV. Japan, of course, and Ariane go back a long way. It's a very long and fruitful partnership. We have another JCSAT-13 in the order book yet to be launched.
BSAT-3c et JCSAT-110R.
But before that, we have successfully delivered our second passenger. And you heard the applause. And the second good news, some happy faces and some happy hats on the Astra side. And the Japanese satellite beginning its life now. It will be picked up by Australia, the first acquisition in about 20 minutes by the Urala station there. 5 apogee motor firings on the first, second, third, fifth, and sixth days. Reflector deployment and solar array deployment in about a week. So, Ariane's mission successfully accomplished again. 2 new satellites beginning their life. We will go to a replay, but before that, the answer to the quiz question. Remember, like tonight, an Astra satellite and a Japanese satellite have flown together on Ariane twice before. Can you name them? The answer is Flight 138, December of 2000, LD Rex, 183 kilometers, flew with Astra 2D. And Flight 149 in March of 2002, JCSAT-8, flew with Astra 3A. That was on an Ariane 4. So if you get any of those answers, give yourselves a round of applause. And your prize will also be, you'll be able to watch the launch replay, which is coming up right now. So you saw those shots from our camera. You relived those very emotional moments and very beautiful shots. that happened about 40 minutes ago as Ariane took off. Another replay from another vantage point now. There are about half a dozen observation posts here in Kourou, and that last one I think was from the post at Toucan, which is the closest to the launch pad. Jean-Yves Le Gall for the first of our post-launch speeches.
Bonsoir. Eh bien, comme vous venez de le voir, ce 59e.
As you have just seen, Ariane has succeeded with its 59th launch, which is also its 45th success in a row, and it has just placed Astra 1N and BSAT-3c JSAT-110R geostationary transfer orbit, and this is good news. Let me first say a word to our customers. This launch has taken place 5 weeks behind the initial schedule, and I want once again to apologize for the delay. I can assure you that we have taken the necessary steps to ensure that this unfortunate situation does not recur in future. But the success of this launch, I think, shows that we did exactly what we needed to do to overcome the difficulties that we encountered last month. And I wish to express our appreciation to you for the confidence you have shown in us over these past weeks. Astra 1N, this is the 11th satellite that Arianespace has launched for SES Astra and the 34th satellite that the SES group has entrusted to us. Let me say to SES that we are particularly proud of your loyalty over more than 2 decades, and I would especially like to thank my friend Martin Halliwell and his entire staff for having entrusted the deployment of their satellite fleet to us over these many years. And I would also like to thank the Austrian teams that built the satellite. BSAT-3c JCSAT-110R is the 41st satellite built by Lockheed Martin Commercial Satellite Systems and entrusted to Arianespace on behalf of BSAT and Sky Perfect JSAT. Let me say to my friends, Joe Rickers, Kazuo Takinaka, and Shigeki Nishiyama, how very much we appreciate the confidence that you have once again shown in us. As you know, Japan is one of our company's major partners. Of the 36 Japanese satellites for which launches were tendered, we signed 27 contracts, and for several years we have had 100% market share in Japan. Many of you have come this evening to share this further successful Ariane 5 launch with us, and I thank you for coming, and I thank all those who have been watching us with us from Évry, Luxembourg, Toulouse, Tokyo, Newtown, Barcelona, and around the world. Since the beginning of the year, Arianespace has launched an ATV to the International Space Station, 6 telecommunication satellites, and 6 satellites for a constellation. I think it's fair to say that this once again shows that Arianespace is out ahead. Since the beginning of this year, our competitors have only launched 2 satellites, and one of them, to my knowledge, did not reach orbit intact. And successful launches like the one we have just witnessed this evening will continue. We have a backlog of 18 Ariane 5 launches, in addition to 17 Soyuz launches and future Vega launches. I would therefore like to pay special tribute to all those who contributed to this success: the European Space Agency and its member states, CNES in mainland France and in French Guyana, and particularly those who are tracking the weather here and who have given us one further example this evening of the outstanding work they can do to give us weather reports. And I wish to thank all of our industrial partners and, of course, the Arianespace operational team. All of you have done an outstanding job, an outstanding job in the face of adversity. So that is what I had to say, and without further ado, I would like now to hand over to our customers, Martin Halliwell on behalf of Astra 1N, and Joe Rikus, Kazuo Takenaka, and Shigeki Nishiyama on behalf of BSAT-3c JSAT-110R.
Shall I keep my hat on? Or? It's just a little tradition that we have here. Good evening, everybody. I'd like to take this opportunity to thank ESA, CNES, and especially Monsieur Legal and the Arianespace team for the successful launch. I'd also like to thank Astrium team throughout Europe for the build and all the preparations of Astra 1N. And personally, I would like to thank the members of the SES technical team that have followed the Astra 1N procurement over the last 2.5 years. Astra 1N is an important 52 transponder satellite that will be used to secure our 19.2 degrees east position, and where it will actually join another 5 satellites co-located. This is actually the first in a sequence of 6 satellites procured from Astrium, which will include Astra 2E, 2F, 2G, 5B, and SES-8. So we have a lot of work to go still on this one. On a personal note, it's 20 years since I first came to Kourou for Astra 1B, and many things have changed throughout the space industry and in the world in general. However, one thing really has not changed, and that is the excellence, the engineering skill, and the passion exhibited by Arianespace and her partners. Please continue this for at least another 20 years. And finally, because I don't like long speeches, so don't worry. So finally, I would just like to wish good luck to Arianespace for the subsequent launches, and very good luck to BSAT-3c, JSAT-110R for the remainder of their mission. Thank you very much indeed.
Boy, a big thank you. I personally want to thank Arianespace as well, ESA, CNES, all that have worked here at CSG to make this launch possible. I always get butterflies at these launches in my stomach. This time I have no fingernails left, I think, after the launch today. It was just terrific, though, to be able, as Martin said, to work with Ariane to get through the issues that we had. Very transparent, very thorough, just a shining star of excellence in working through some very difficult issues with us with this launch. I want to welcome all of our guests out there that are watching. Many of you probably on the internet. We've had events scheduled where we could have people come watch the events, and due to the schedule slipping out, many are probably watching on the internet. Early morning, Sunday morning in Tokyo, welcome. To all you in the control center in Newtown and the Lockheed Martin employees that are spread throughout the United States, welcome. I know many of you have worked very hard on this satellite, and we have more work to go yet. We will do our orbit raising maneuvers over the next week, roughly 5 orbit raising maneuvers. We'll do deployments in a little over a week, and then by mid-September we plan to hand over to our 2 customers, to Sky Perfect JSAT and to BSAT. I want to thank Mr. Takenaka, Mr. Nishiyama. Thank you very much. The partnership here in buying this satellite together and the work has been great. And you really are a couple trusted customers of ours, and we'll hand over a perfect satellite to you here in September. Again, thank you, Jean-Yves. Terrific launch. It was one of the most spectacular that I've seen down here as we get to see those go outside and see those go. We saw that rocket light up the sky well into the night. So thank you all.
Well, firstly, let me take this opportunity to congratulate all the Astra members for the successful launch today. It is certainly my great pleasure to be here to share this exciting moment with our partners, including Mr. Nishiyama and people from JSAT Sky Perfect JSAT Corporation. Let me also express my sincere appreciation to Mr. Lugalo and his associates from Arianespace for their professional work. That has contributed for today's launch. Today, I'm quite impressed by the outstanding performance again, following the successful launch which took place last October for our BSAT-3b. Even though this launch was postponed for 5 weeks, we still admire the professional work of your team for leading this project to the success. I deeply appreciate Ariane people's effort. Thank you. I also extend my deep appreciation to Mr. Joe Rickers and all our fellows of team of Lockheed Martin, who has demonstrated their proven quality of work in all satellites of the BSAT-3 series they have delivered to us. Thank you, my fellow members. 東京で再びご覧の皆さん、日曜日の朝申し訳ありません。ご支援ありがとうございました。Sorry. As you may well know, on March 11, our country got hit by monster quakes and tsunami, killing over 15,000 Japanese citizens. Our people are still suffering from the tremendous hardship since this once in 1,000 years of natural disaster. Along with the serious damages caused by this incident at Fukushima nuclear power plant, we have further strengthened our belief that fast and accurate information flow is vitally important for the society, especially in such a critical situation facing our country today. In this regard, the BSAT-3c JCSAT-110R launch that we witnessed today is certainly not a small event taking place on the other side of our planet. I strongly believe that it will encourage millions of people back home who are working so hard both night and day, trying to restore the local communities from such damages of tsunami and the quakes. I know that they will find this as a new hope and a dream for such a restoration effort for the future. In closing my remarks, I would like to once again thank everyone who made today's launch possible. I would like also thank French Guiana for providing the venue for the launch. Deo gracias. Merci beaucoup.
First of all, I'd like to say congratulations for everyone. I have been waiting for this launch for a long time, maybe more than 1 month. Today, it is my greatest honor to be here again and witness the delivery of newborn baby, JCSAT-110R. To begin with, my thanks goes to Mr. Rugar, Arianespace, and associated personnel at CSG for their hard work to carry out today's launch. Although this is the 13th Arianespace launch for us, it was my very first witness of actual live launch and undoubtedly one of my most impressive experience in my life. In fact, I feel like I'm still hearing us rumbling. Secondly, I would also like to thank Mr. Rickers and Lockheed Martin for their 30 months long effort to deliver flawless product in time. For us, this is the 5th A2100 satellite we have more than 100% confidence on your performance. In the meantime, we'd like to ask your continuous favor to nurse the satellite until the final handover. Thirdly, we'd like to share today's delight with our partner, Mr. Takenaka and Mr. Yabashi from BSAT, and your staff, who shared hard to push forward this hybrid satellite project with us. And finally, I would like to enjoy this previous happiness with SES and Astra Group, who share the ride with us with us on top of Ariane 5. Ever since March 11, our country has been depressed due to massive casualty of super huge earthquake and devastating tsunami hit northeast Japan. I know today's successful launch means nothing for their victims, but I pray in earnest, wishing it would cast a light of hope. Now looking back the year 2008, our aim of having JCSAT-110R was to back up NSAT-100 satellite, which is providing digital multi-channel broadcasting service, named E2. We then had more than 700,000 subscribers. If I look over the present business environment, operating backup satellites become mandatory because E2 has become our primary DTS driver for the last couple of years. In fact, the number of subscribers grew to more than doubled compared to that of year 2008. Accordingly, I'm so delighted to see that we have safely passed the most risky and the fierce part of the project, thanks to smooth and precise ride on Ariane 5. From now on, the satellite will undergo initial functional check on stationary orbit for about 1.5 hours, and be finally handed over to start nominal commercial operations. Again, my deepest gratitude to your kindness for giving me an opportunity to share this special event. And thank you for listening. Thank you very much.
Bien. Donc, Monsieur Halliwell vous a dit que
Mr. Halliwell told you that he had been coming to French Guiana for 20 years and that he always liked to come back. I can tell you that I've been coming here for 25 years and that I always enjoy coming here, and I will be coming back here next month because the next Ariane 5 launch will take place on the 9th of September. That will be a launch once again for the SES group, one of our best customers. It will be the SES-2 satellite, and it will go with the Arabsat-3c satellite for Arabsat. And I believe that Arabsat people will be watching us from Riyadh. So the next launch, the 60th, will be taking place on the 9th of September. Good evening.
Well, that'll do it for us from Kourou, where the big news is Ariane 5 has once again delivered. A bit of suspense with a hold in the countdown, but all's well that ends well. 2 new telecom sats beginning life, Astra 1N, BSAT-3c, JCSAT-110R. 45 straight successes for Ariane 5, 31 straight for this version, the Ariane 5 ECA. The next launch you heard, September 9th, another satellite for SES, SES-2 with Arabsat-3c. Until then, from Kourou, Joshua Jampol, on behalf of everybody here at Arianespace and the Space Base, saying thank you for being with us. We hope you enjoyed it, and we look forward to being with you next time. Good day.